let's get started. Today's presenters are Shai Maskett, Director of Product and Solutions with Kaminario, Chris Buckle, Director of Sales Engineering for Kaminario, and Jeff Garbus, CEO and founder of Soaring Eagle. So Shai, whenever you're ready, take it away.
Thanks, Emily. Good to be here. Good to have this webinar. Before we get started, I just want to allow Jeff and Chris to introduce themselves, both database experts and with a very impressive track record in the database area. So, Jeff, how about you tell us a few words about yourself?
Sure, happy to. First, thanks for inviting me out to play today. I'm looking forward to chatting with anybody who's going to be on the system. My background, I've been working with databases, I started out as a programmer when I was 12. When I got into my early 20s, and this was a good 30-plus years ago, I discovered databases and fell in love. So I guess I've been involved with SQL Server in particular since the late 80s, so back when OS/2 was a cool technology, and my skills are still very current. Work also with Sybase ASE, a little bit of Oracle, a little MySQL, a little Mongo, a little bit of the extra stuff. My company does database performance tuning, systems admin, a lot of database managed services. The rest of my background is administrative and a little bit of management. I brought my first company public, so I've run the gamut. Oh, 20 books in print in case anybody's interested.
Okay, Chris, Mr. Chris Buckle, please present yourself.
Hello there. So my name is Chris Buckle. I am the Director of Sales Engineering for Kaminario out here in sunny England. I look after the European and Asia Pacific regions. I've been working at Kaminario and before that in the storage industry for a number of years, but don't let that fool you. I'm actually a database guy at heart. I spent 15 years working with databases latterly for Oracle Corporation in the UK, and I run a blog and online community called FlashDBA.com. So I'm kind of masquerading as a storage guy today.
Okay, masquerade away. Okay, so with that, let's kick off with a warm-up question. I'm going to direct it to Jeff. Jeff, what do you see as the number one driver for organizations moving to all-flash storage?
I'm going to give you a two-part answer to that one. My focus generally is database specific. So you're talking about an entire organizational move to all-flash storage. My entry point is generally somebody calling me and saying, our databases are running slow, can you help? So what we'll do is we'll perform some analysis, and for example, a recent one, what we found was that only about 30% of the performance was running into DBMS. About 35% of the performance was disk latency, and another 30% of the performance was getting the information off the disk into the cache. So what we did was we said, well, the first thing you've got to do is get faster storage, and the second thing you've got to do is get a bit more memory. So the organizations that I'm dealing with move to all-flash storage primarily to get rid of their disk latency for the databases. The next thing that happens, though, is they realize that the flash storage was dramatically less expensive than they expected. I have a customer right now that just got rid of, I'm not going to tell you what the brand is, they just just got rid of a variety of their LPARs, and they justified replacing 100% of the organizational storage based on the first-year cost and licensing, power, and storage space for the flash storage. So that's actually the third time that's happened to me in the last several months.
Interesting. We actually have collected some data, survey that supports the exact same findings, that, high performance, where you get your database not performing as you would like, would be the number one driver. Chris, what do you say?
I think it's certainly, as a rule of thumb, I think that database and applications people spend a large portion of their time fighting performance issues. It's certainly what I see when I speak to customers, and it's certainly what I saw when I worked in the database industry as well. I think that we're going to cover databases in a minute, but I think that a lot of performance issues come from building applications which are designed with application logic in mind, but aren't designed to scale out to support large numbers of customers. And it's all about the scalability in the architecture, whether that was designed from the beginning or not.
Yeah, and if I could add to that, what we see a lot are that the folks who design the applications aren't always told the truth about how many people are going to end up hitting the application subsequently. I humorously call Jeff's first rule of prototyping that the faster you slap something together, the more likely it is to go into production. And then the corollary to that is, and the more often you are, more likely you are to be judged by that at some future point in time. So one of the things that I see frequently is that people will put up small applications for the purpose of saying, yes, we can make this work. Suddenly it's gone through QA. QA's got 30,000 rows of data instead of 300 million rows of data or 30 billion rows of data, and nobody has done that type of testing.
Well, you know, Jeff, I've done that role in my past, a long time ago, but you know, I've sat there in a development office staring out the window, drinking my latte and thinking about, you know, the code that I'm writing in Java or whichever language, but not thinking about what happens when 1,000 people do this action at the same time, or 10,000 people do it within the same minute. You know, it's a state of mind that goes right back to the application design.
And part of that goes back to deadlines as well, because they don't always give you time to drink your latte and think those deeper thoughts.
Well, trust me, there's always time to drink your latte.
I know, but then it rules out the deeper thoughts.
Right. So, you know, maybe with those spinning disks delivering poor performance, you might have time, you know, between queries to drink your latte, not so much maybe dealing with all-flash storage. Interesting. Okay, so I have a next question for you guys. And again, what would drive performance for those enterprise applications? Jeff, why don't you start?
Sure. This is a really broad question, so I'm going to first start with how I look at an application that is not being perceived as performing sufficiently. So what I do is the first thing I look at is the overall gestalt of the system. So is the disk fast enough? Do I have enough throughput with the network I/O? Do I have enough memory? Do I have enough CPU? And I look to see if there are any high-end quick fixes, because CIOs, and I'm not trying to offend any CIOs on the call, like to throw hardware at a problem because it's much cheaper than throwing an application development team at a problem. If the solution is let's get faster hardware, then that's a really easy answer. The next thing I do is look at the application itself. Are we missing indexes? Is the code bad? Is it, you name it? The Gartner Group and Microsoft's internal numbers claim that 70 to 80% of application issues belong to the application programmer. I haven't really found that, either that or I usually get brought in after the application folks have already taken time to tune. What I found a lot of database issues boils down to either proper indexing, proper architecture and design, or the hardware was not properly scaled for the application, or sometimes the application scales in a surprising way. For example, we've got a customer, an SaaS vendor, that bought 4 of his competitors. Well, all of a sudden you've got 4 times the volume in a very short period of time, and sometimes the hardware is not up to it.
Interesting. Okay, Chris, how about, you know, if you look specifically at Oracle, is there any specific symptoms that you would recognize?
Yeah, I think just to touch on what Jeff said then, you talked about how one alternative is to bring in a team of application developers. That's typically more expensive than throwing hardware at the problem. I think just to build on that, it's also much more risky, right? Because there's no guarantee that your team of application developers are going to make anything better. they're going to spend, maybe 6 months working on the project, but you don't know whether you're going to get a guaranteed conclusion that works for you. Whereas throwing hardware at the problem, everyone knows it's not the right answer, but it is the answer that typically costs less and, has a better likelihood of achieving success. I spend a lot of time going in to see customers, and I tend to look more at Oracle databases because I'm an Oracle guy, through and through. I stay away from SQL Server because it scares me. But the symptoms are, I think, pretty similar. So if you think about a typical transactional workload, what we call OLTP or online transactional processing, this is applications like CRM or ERP. It typically involves lots of small amounts of data being read from storage onto records on a screen, let's say, for a CRM application, and then maybe small amounts of data being changed. This is what we call a random workload. So for a legacy disk-type storage platform, there's lots of little disks somewhere in the data center having to spin around, little heads moving across the disk to find the right sectors. That incurs lots of penalties of latency, lots of delays. And transactional databases, they're probably the hardest workload for storage to have to deal with because they're so heavily random. In Oracle, the typical wait event that Oracle DBAs would see is a thing called DB file sequential read. DB file sequential read is actually a random read. I don't know, it's like a dark joke that Oracle decided to call it that. But any database which sees a large amount of wait time on DB file sequential read is bottlenecked on random I/O on storage. There's other wait events as well. There's things like the redo logs, writes, for example, when large amounts of data are sorted in memory and they spill over to storage, that involves lots of reads and writes. But having met hundreds of customers all around the world, it's always the random reads that are the biggest problem. And just one other thing to mention there, even when a user is updating data, even when they're doing an update or an insert command, you typically have to incur a read first to go and get the block from storage to make sure it's consistent before you can update it. So even writes are bottlenecked on reads. And if you look down at the last point on the slide there, which is about throughput, that's a different type of workload, what we call OLAP, online analytical processing, or data warehousing, business intelligence, analytics. There's many names for it, but it typically involves reading a huge amount of data to generate summary statistics, averages or whatever, or identify trends. And that typically gets bottlenecked on what we call throughput, which is the ability of storage to shovel a large volume of data into or out from the server. Those are the main kind of areas where databases, particularly Oracle databases, tend to struggle with storage.
Thanks, Chris. That's good stuff. Jeff, how about, can you share with us maybe with the same problems, maybe of storage I/O, but with the lingo of SQL Server?
Sounds great. And Chris, if you'll handle all the Oracle-related questions, I'll take all the SQL Server-related questions. And
that's a deal.
Great. So on the SQL Server side, let's talk history for just a moment. Chris touched on spinning disks, and I do see spinning disks out there, but what we do historically with SQL servers would say, okay, if we have some faster disk, we put the log and the tempdb on the faster disk. Maybe we put the system on the faster disk, or if we have a small amount of in-memory database or solid-state disk, that's where we put the log and the tempdb, because that tends to get hit quite heavily. And I have to agree with Chris that the read performance becomes critical, but that tends not to be where the SQL Server ends up bottlenecking. The SQL servers tend to bottleneck a lot faster as you start looking at things like the log and the tempdb contention. So if you look up at the high storage latency button, it says high latencies for page I/O latch wait events. What ends up happening a lot is that when we go off and try to bring a page in, the first thing we want to do is reach for the page. Then the other thing we want to do is grab a latch so that we can identify where in storage we want to put things. So In a multiprocessor system, and today everybody's system is multiprocess, multi-thread, multi-core, we need to make sure we don't step on each other. So that latch is a terminology. A latch is a non-transactional lock that lets us go out there and make sure that we get that page of storage that we're asking for, so we can bring the page off the physical disk into the storage. So there are maybe 5 or 10 different I/O latency indicators that you'll see in SQL Server. Anything regarding latch really is getting the page from the disk into memory, and it is wait time on top of getting the page off the physical disk. So from the spinning disks to the mixed storage, the next step in evolution were the nimble type devices, where you'd have some flash or solid state. You'd have some 15,000 RPM devices, some 7,000 RPM devices, or whatever that step down is. And then the idea behind the nimble architecture was that it would dynamically identify what needed the faster disk and move stuff over there, stuff being my technical word for the page or the databases or the files or whatever it is you're trying to read. So what that brought about was people calling and saying, hey, this has run great for months, and all of a sudden it's 5 times slower, and we just can't figure out why. The storage people are telling us that we are well within what we've asked for performance and service level agreement. Can you come and take a look? And I remember one of these fondly where I went in, and it turned out that the vendor had told them they needed 10 millisecond response time from their storage. Their storage people were getting them 5 millisecond response time. The problem was, for several months, they were using it wasn't a Nimble, it was a storage device that did something similar. They were getting 0.5 millisecond response time. So when they went from the 0.5 millisecond response time to the 5 millisecond response time, obviously everything got 10 times slower. They were complaining. The storage people were saying, hey, you asked for 10, we gave you 5. I don't see the problem. And it becomes an expectation thing. One of the things that we look for as a critical component of performance is consistency. If we don't know how fast the data is coming off the disk, we can't measure or make a consistent approach to identifying how long things should take. And our users think we're not competent because we can't consistently return queries with the same amount of data. So things like log and temp DB, we want that on the faster storage. Read performance, as Chris said, absolutely critical. And it says low throughput, but I've never seen a low throughput application really. Everything wants the data. They want it faster. They want it quicker. They want it aggregated more quickly. They want it off the disk faster. Getting it off the disk, of course, is coming through memory and back out through the network or whatever channel you've got moving. I think I've just wound down.
Yep. Okay, so I think if we try and summarize it, we see that applications are hurting because of the database performance, right? If it's the underlying database will return, the queries will return slowly to whoever requested them, so the online response time will also be slow. Or if it's batch processing, if it's the low throughput that is driving those low batch processing to finish after the maintenance windows are already completed, and that of course leads to SLAs not being completed and really timeouts as far as the different layers within the stack. And we were talking about before that, at times you could develop on the application layer and maybe solve that. And a lot of the time, it's actually the hardware infrastructure that needs to be replaced. And Chris, this question, let's start with you this time. So what would be the role of hardware? I think you touched about it a bit, but maybe you can expand about what's the role of hardware in helping optimizing database performance.
Hey, Shay, can I back you up one slide for a moment? This is Jeff.
Yep.
I want to add 2 comments on this slide. The first is that third bullet item that says not being able to meet SLAs. One of the things a lot of folks at the application teams and the DBA teams aren't aware of is that as you move higher up in the food chain, director level, C level, those people frequently have their bonuses tied to meeting these SLAs. So if you ever want to find yourself in a room with somebody giving you a very hard time, cost a C-level person their bonus because your performance isn't good enough. And when you talk about the SLAs, you talk about business, you're talking about contracts, you're talking about expectations within an organization, which frequently have reactions both outside the organization and also up to the board level. The other thing about the SQL queries leading to slow online response times, I was brought in to do a performance and tuning gig for an internet-based company a couple of years ago that had performed that quantitative analysis. Their marketing people told them very specifically, and this was not a large company, that for every second in improved performance, they can gather about $75,000 per month net increase in retention and sales, coming down from a 9-second performance down to about a quarter of a second performance, which is what we brought them. So these things are more than just, make the programmers happy, make the application teams happy. It is organizationally critical to do this just so that you can make your bosses look better, because they will know who did it and they will come back and they will thank you for it.
Yeah, what's interesting about this slide, I think, is that what I've discovered in moving from databases to the storage world is that we all speak different languages, right? So someone in a database world might talk about wait times, someone who looks after operating systems talks about OS wait, and in storage we talk about latency and we talk about throughput. We're all talking about the same thing but with different words. This slide really kind of summarizes storage issues but in the language of applications and databases. So if a storage platform has a latency problem, the DBA won't know it has a latency problem, but they will know that SQL queries are taking too long, right? And somewhere, someone is trying to load a screen in their CRM application and sitting at their desk getting really impatient because it's taking too long to load. Or in the case of throughput, again, which is, as Jeff said, the ability to move lots of data around, I don't think there's a DBA alive today that didn't have this issue at some point in their career, where you have a batch job that has to run in a certain window, normally out of daytime operation, maybe overnight or over the weekend. And over time, as data volumes grow, it just gets longer and longer until eventually it spills out over the window and starts affecting the performance of the next day or the next week. This is just a great way of thinking about storage problems, but with an application or database focus.
Yeah, and to add one thing to that, as you start thinking about monitoring technology, it becomes absolutely critical to make sure that your monitor can pay attention to things like disk latency and associate that back to application performance.
Absolutely.
Yep. Good point, Si. Good point.
Thank you, Shay. I apologize for throwing you off a little bit and asking you to back up.
No, that's fine. But I think that for some reason we jumped a few slides ahead. So I'll just have to go back to my original question to Chris this time. So again, repeating the question, what's the role of hardware in helping optimizing database performance?
Sure, okay. So one of the reasons I really enjoy my job is I get to go around the world and meet lots of very interesting customers that run some of the world's most critical databases. And those customers typically have an issue, otherwise they wouldn't be asking to see me. And so the issue can come in many flavors. It can be to do with it can be to do with user experience. It can be to do with the inability to serve data in time to the business. But, whatever they're asking for, the same underlying kind of request comes out, right? Just make my database hum, fix my application for me, please, right? Take away these problems that I've got. And, typically it always does come down to storage performance. Now, you have to bear in mind that I work for a storage company, so that's probably why they're asking to see me. Jeff, you get to meet a lot of people with a lot of different other problems, but it is typically the storage platform that has this effect on the applications that they're using to run their businesses. And I've dealt with customers using many different database products, whether it's Oracle or SQL Server. There's a whole host of new types of, what are now called NoSQL databases out there for unstructured data. But the same kind of underlying objectives come out, which is this need to remove wasteful latency. Latency is just time wasted that could be used to serve data to your customers. So minimizing latency, coping with increasingly random I/O. I think what's interesting is that as database workloads have started to become more and more virtualized, you find more and more virtual workloads running on top of each other on the same physical infrastructure, and that has an effect, what we call in the industry the I/O blender effect, where I/O becomes increasingly random. And possibly the most important thing, which I think we're going to talk about next, which is the ability to run lots of mixed workloads concurrently. And typically what I've been able to give these customers is a massive improvement in performance by switching to an all-flash solid-state platform. And when I say a massive, I'm not joking. We're talking about 2x to 5x kind of improvements.
Okay, that's impressive. 5x of performance. That's pretty impressive. Jeff, what do you see when coming from the hardware angle to solve database performance issues?
I have to echo a lot of what Chris says. What we found over time is that we've got a finite number of bottlenecks at the hardware level, right? We've got CPU, we've got memory, we've got network, we've got disk. Over the course of time, CPU as a bottleneck has become easier to fix because we can get faster boxes. At this point in time, we can buy a box that is going to exceed almost any set of criteria that we're going to come up with from a CPU standpoint. Most of those boxes will handle more memory than you're willing to pay for. We can go with fiber or multiple network cards to get the throughput. Then the next step becomes the disk, and of the four of those, I do see disk as the most frequent issue with latency in those database environments. And from a really fun example, we have you had software as a service listed up there on an earlier slide. One of our customers, who's an SAS vendor, brought us in. They are hosting medical records, so a lot of things become critical right there. And they have said, and I'm paraphrasing a little bit and using kinder language, doctors do not have patience to wait for 11 seconds for a record to come up on their tablet device. So the ability to get the data back to the people who are using it is very important. This particular vendor, they were a hosting company for a third-party medical record software product, and so basically they went to a doctor's office, they resold this third-party product, and they did the hosting for it. Once they got that in there, they found that 11-second barrier was difficult because they had gone to the vendor and said, hey, 11 seconds is too long, and the vendor said, well, that's what you've got. So they brought us in, and we did a number of things. This was one of the examples we used earlier. We did tune the queries. They were missing a lot of indexes. That made the whole system about 65% faster. We were only using about 35% of the CPU we were using before. But at that point, they said, okay, still not good enough. And we went in and said, all right, memory and disk not in equal proportions, but bringing back equal returns. And we took that 11 seconds down to 2 3/4. So the client we had was a little bit of a character, and he went to the next convention for the third-party application vendor, and he said, and he asked them publicly with everybody listening, so how long does it take to do X? Doctors to bring up the records. They said, sorry, you got 10, 11 seconds, best case. We simply haven't been able to improve on it. And he said, I'm getting about 2 3/4 seconds, at which point he pretty much took over the session. Everybody was listening to him instead of the rest of them. So being able to identify where that bottleneck is, being able to apply the hardware in the right place, is absolutely mission critical to getting a lot of applications to perform properly.
Jeff, you mentioned software as a service there, and I think that's a really interesting industry. I actually worked for a software as a service company before I entered the storage industry, so I have a bit of familiarity with the challenges of SaaS. And Kamanario has a number of SaaS customers now, a very large number of SaaS customers. And I think SaaS is kind of leading this trend that I see now, which is the requirement to run what we call mixed workloads. So we talked about transactional or OLTP workloads before. People are also running their batch workloads or their business intelligence, their analytics. But increasingly, we see customers needing to do this on the same platform in real time. And the SaaS is a great example of that. You simply can't afford to take a delay while you shard off a copy of your transactional database and put it somewhere else and run your queries on it. But equally with SaaS, because it's normally a global operation, there is no out-of-hours window. There's no quiet time at night. So you have to run your transactional and your batch jobs concurrently. And that ability, the ability to run mixed workloads, which from the storage platform basically means a very unpredictable workload. So it could be reads, it could be writes, they could be random or sequential, they could be small, they could be large, but they're all coming at the same time. And that is the next real challenge of database storage, I believe.
Yeah, and one more performance tip for those who are on the line. Storage as a bottleneck is something that, I mean, you've been doing this for a long time, I've been doing this for a long time, and I think we have always said treat storage as a bottleneck. This helps eliminate that brain direction of treat storage as a bottleneck. But the other thing you have to keep in mind, particularly in the SaaS environment, and for particularly those who have single-tenant versus multi-tenant environments, which in things like medical records is going to happen frequently because customers are going to require it, sometimes you need to make sure you get sufficient memory to deal with the stuff that's coming off the disk, stuff being my technical word for the data pages, of course. Because what ends up happening is if you've got 200 databases instead of 2 databases, all of the metadata for the individual databases starts taking up a lot more space. You have 200 times the root pages going into critical tables and 200 times the intermediate pages, and the disk stops being the bottleneck, and sometimes you shove the bottleneck from the disk over to the memory. You just need to make sure that doesn't happen. It's a very inexpensive add-on to make sure that getting really fast disk gets you the full benefit.
Okay, good points there, guys. I want to take you, Jeff, back to something that you said before about the true business value when you use optimized flash storage. How does that tie? How does these two tie together? Optimized flash storage and the business value. So we talked about, if you bring up a bonus of a C-level person, that will get you notice, that's a very good tip. But other than that, how do you see those two tying up together?
Wow, I think that's probably a 2-hour talk all by itself, so I'll try to be brief enough to do the rest of the slides and give Chris time to talk too. I'm speaking at a C-level conference next week in Boston, and they told me I was speaking at it last week, so I in a hurry, I had dinner with a C-level friend. He's a CIO, CTO of an SaaS company that we were doing work for. And I said to him, Eric, what would you want to hear from me, a database geek, if you were going to listen to me at a conference? And he spent the next 20 minutes giving me a list of great topics and practically wrote the webinar for me, which is great. But C-level as in, Boston's pretty close to C-level, isn't it? But one of the things he talked about was to make sure that I talk about the business aspects of things, because the idea that we're suddenly taking up a lot less physical storage space gets you a lot of benefit as you, as a C-level person, go to your board and say, I'd like to justify the cost. The fact that the electricity costs, electrical costs are reduced, very significant. The fact that the licensing costs are a lot less. And he said, you know, I just sold him the Common-Ario, and he said, Jeff, I justified this purchase by saying that we were going to be paying for the cost of the equipment in the first year over the licensing costs of the last part of the equipment. And in fact, when my chairman, who's also the owner and owns hospitals and owns an incredible number of businesses, said to me, you know, we can take that old LPAR and put it in the hospital. My friend Eric said, no, don't do that, because it's cheaper to go buy the flash storage than it is to pay for the physical storage, the connection, the electricity, the licensing. Just sell it and get rid of it. It was pretty significant. It was a great conversation to have, because as a database geek, I tend to think in terms of, okay, we have 3,000 people all dialing in. This is a real life example. We've got 3,000 people dialing in. It takes them 30 minutes to download their schedules for the next couple of days, and they all complain about it. Well, when we take that down to 2 minutes, all of a sudden we've saved 28 minutes a day times 3,000 people, and that's the kind of math that I tend to do. I don't always tend to think of the math of, well, okay, we're eliminating storage space and we're thinking operations. I'm sure Chris thinks about that all the time, but I'm usually doing more the human math than the resources math.
Hey, Chris, how about from the point of view of the storage itself? I mean, how does moving to flash storage would prove as a business benefit as far as the expenditure is concerned?
Well, I think there's always two types of benefit. When we talk about the costs, there's two types of benefit, right? You've got the intangible benefits, the ones that you can't really measure, right? What happens when 1,000 people in a call center can now access their CRM screens 5 seconds faster for every single call they take, right? You multiply that 5 seconds across 1,000 people, across however many calls they do in a day, and keep going, make that over a year. That's an incredible effect, but it's very hard to actually put a number against it, which is unfortunate for someone like me that works in a sales organization. Having said that, when customers are moving from their legacy disk arrays, what I'd like to call 20th century storage, and they're moving on to modern all-flash storage, you're typically getting a huge benefit in terms of the total cost of ownership, and that comes from the fact that you're no longer powering all those horrible spinning disks. Right? So you're talking about typically a 90% reduction in power. The disks, because they're not there, aren't creating all that heat, so you're talking about a 90% reduction in cooling. And even more importantly, you can fit much more data in the same physical space, because flash is denser and it gives you the ability to use data reduction technologies like deduplication and compression. So you can often go from many square floor tiles of disk arrays down to maybe just a few rack units of all flash array. And when we talked about SaaS companies quite a lot, a very common model for a SaaS company is to host their systems in someone else's data center, in a colo. And in those colos, you pay for power, you pay for cooling, and you pay for physical space. So if you can reduce all of those things by 90%, that has a drastic effect on the total cost of ownership, and you're often looking at a return on investment that's measured in months rather than years.
Okay, thanks, Chris.
Hey, can you back up a slide again for me?
Yep.
Thank you. One other point I'd like to make on this slide, one of the really smart things that a flash storage vendor does is to handle at-rest encryption at the hardware level. And if you look down there at the bottom right where it says native hardware compression, if you're using encryption tools at the software level, what ends up happening is that the ability to perform compression is reduced because you don't have the ability to get similar things to do the deduplication and the compression, because it all looks different. Doing that at the hardware level is another component of this whole increasing the amount of storage capacity and less physical space, because you do the encryption. You can do the encryption after the compression. You get the at-rest encryption, and you already have that 30% benefit of the compression, which is harder to get if you encrypt at that software level.
Good point, Jeff. It's a good point. Definitely, when you come to think of workloads,
actually, if I could just say, Jeff, going back to that slide, I think what you're referring to there is the idea that you can have technology like compression in many different layers, right? So, for example, many database products like Oracle and SQL Server will allow you to compress the data in the database. You then got the ability to compress or deduplicate data on the storage array level as well, right? And in some cases that can be beneficial. In some cases you can actually have those technologies conflicting. One of the things that we've tried to do with Caminario is give customers the ability to choose. For example, deduplication, which is a very important technology, is something that is selectable on a volume level. So if a customer feels they won't get any benefit from it because, for example, they're using Oracle and Oracle blocks have a unique sequence number in them, they can choose not to use deduplication and save some, valuable extra CPU cycles and therefore some extra latency.
Yeah, thanks, guys. I apologize. I got disconnected for some reason. I'm back on. So I heard you talking about deduplication and why being able to select it is not, you don't waste cycles on trying to dedupe data that it won't dedupe with these unique sequence numbers in them. It's a good point. Just want to, Chris, if you mind going through some customers that Caminario has, as far as what they have been seeing, as far as how we made their databases hum.
Yeah, sure. I'd love to. The example you've got on the screen there is Clearwater. Clearwater is a very interesting customer. They're a software as a service company. We've been talking about this a few times today. They provide software for investors to manage their portfolio and to run analytics, data aggregation, compliance reporting, and risk analysis on their portfolios. Like any kind of financial technology company, latency is very, very important to them. So they were having quite a lot of issues with their legacy storage systems, and those were affecting the databases, those were affecting the applications, and at the end of that chain, you've got customers who get a lesser user experience than Clearwater would have liked. And one of the big challenges of SaaS companies is that customers, while they can adopt SaaS very quickly, they can also walk away and go to a rival very quickly. So user experience is extremely important to SaaS. What Caminario was able to do by replacing the storage for Clearwater was allow them to reduce their... they actually do a process called reconciliation, which is a kind of a batch process. We reduced those reconciliation times by 75%. We also reduced the times of all their longer reports by 65%, and they had a notable improvement in customer satisfaction. So the performance benefits that we gave them had a great effect on their business. And when we came to do a case study with them, we asked James Price, who was their Director of Product Development, we asked him to just explain in one sentence, why he chose Caminario. We expected him to say something about performance, and you know what he said? He said the number one factor was the cost. The cost in dollars per gigabyte, we just couldn't overlook it. So even after all the things that I've talked about performance, the cost was the reason that they chose us.
Yeah, that's a good story, and I think the images we see here, how the latency used to spike and was totally inconsistent and very, very high, by the way. I guess for some of the viewers who might not be able to see it, there is a line of latency. It's just extremely, extremely low, and you can see that after the implementation of the K2 all-flash array. That's on the right-hand side with the purple.
That graph is very interesting, actually. If you look at the spikes on that graph, what you can see there, I'm sure Jeff will recognize this, is that's what happens when you try and mix workloads. Right? That's what happens when you run reconciliation, which is a very sequential workload, at the same time as your users are using their transactional workload.
Okay, cool. How about we talk about another customer of Combinario, an interesting one. Oh, it jumped. I apologize. eToro. Chris, what can you tell the guys on eToro?
eToro is a very unusual company. So again, it's a SaaS platform, as it happens, and it's actually similar to Clearwater. It's in what you might call the fintech space, financial technology. But for eToro, what they do is social investment. It's kind of a social investment network. So let me try and explain that. Typically, when you log on to an investment platform, you make trades, you buy and sell, right? And you do it in the privacy, knowing that no one else knows what you're doing. With eToro, everyone can see what you're doing. You can see what everyone else is doing, and customers can identify users that are being more successful and follow them. And you can even get to the point where you can enable this functionality they call copy trading, where you say, this user, I will have eToro automatically copy every trade they make because I want to share the success that they get. Now, that's fascinating, but if you think about it from a database perspective, you end up with, a couple of users, like what you might call very successful users, where when they make a transaction, a huge kind of chain reaction kicks off in the system of many more transactions that they don't even know about. And what you can't have is these very successful users having performance issues because they're waiting on, trades that they're not even directly involved with. So it was very much a latency issue for eToro. And, at the end of it, when we moved on to the Combinario platform with the mixed workload capability, that we have a functionality called adaptive block size, they were able to achieve 80% faster trading times. So, 80% faster, that's that kind of 5x performance increase that we were talking about. It's a very real number.
That is impressive. Yep. Also the idea of the company itself is very interesting, but to know that there's an all-flash array there of Combinario making that trading go faster, that's some good stuff. Well, guys, we reached the end of the presentation. I would like maybe just to talk about Combinario and Soaring Eagle at a glance. So, Jeff, would you do the honors to start, just talk about your consulting firm a bit?
Sure, happy to, and thank you, Shay. We are an all-expert group of database geeks. We spend about 70% of our work right now is full-blown database managed services. We will take on anything from the basic operational support of the databases up through performance SLAs. Our team is 100% onshore. We are not a huge company. We've got about 12 or 13 people on payroll, another 20 or 30 people who are consultants that we keep busy full-time. We are based out of Florida, but we have databases everywhere, which is one of the nice things about remote database administration. We do a lot of consulting as well, a lot of health checks, a lot of 1 week, hey, it's hitting the fan, can you help us? We also have a lot of fun with the folks who say, we just brought another consultant in and he didn't do anything. Do you think you might be able to help? That's one of the more fun ones for me. Our expertise, database administration, performance and tuning, scaling, high availability, database management. We do most of the major databases. We've talked about them, and our target customers are everything from startups up through Fortune 50. Nice.
I'll just give you some details about Combinario. Combinario is an all-flash array vendor and led by a very strong team built from veterans from various storage companies, headquartered outside of Boston, Massachusetts, and with a very big R&D center in Israel, offices also in London, Paris, and Seoul, South Korea. Our product is now in its 6th generation, very, very cool features and functionality, and a lot around the storage efficiency and density of very, very cost-efficient all-flash storage. We are basically a software company, so we take off-the-shelf commodity hardware and we bundle everything up together with our secret sauce, which is the software, and then we deliver a single appliance, the K2 all-flash array. So basically have a single necked choke as far as service and warranty. Our customers, we just gave you an example of two customers, but really a global 2000 companies, a lot of SaaS companies and online businesses, really spanned also geographies and also verticals. And basically what we do is we enable our customers to scale their business easily and cost efficiently without any compromise. With that, I would like to say thank you, and I would like to reference some of the questions that we got during the webinar. I'm afraid we won't be able to address all of them right now, but we'll definitely follow up on them. So a few of the questions here, I think we answered during the conversation, but you know, I'm going to use a few. Jeff, this one is for you. Are there any good free tools to test a live SQL database performance? Live SQL databases performance.
Free is a very dangerous word. There are certainly a number of products that do a great job that you can get a demo version of that will last for a couple of weeks. I am not aware of any good freeware where I'd be using it. Do we want to talk product names on this webinar, or is that inappropriate?
I actually, if I could just say something, Jeff, and then I'd be interested to know whether you agree with this. There is no way of testing with an artificial or synthetic tool that will ever give you the results that compare to your real-life workload, right? And I've seen this because I've been involved in a huge number of proof of concepts with Kamanario and other storage companies, and you know, you can take a synthetic benchmark tool and you can work out the maximum performance and the minimum latency and all of these kind of numbers. Most people get obsessed with getting a hero number, right? But it won't mean a thing, because when you put your real-life application, your real-life workload, the pattern that creates, the kind of fingerprint that creates on storage will be completely different. So at the end of the day, that's the thing you need to find a way to test.
I agree with you 100%. I may have misunderstood the question. I thought the question was how to take a look at an existing workload as opposed to how to take a look at a manufactured workload, but I agree 100%. And in fact, if you buy a couple of beers for a vendor at one of the large testing organizations, or the vendors of the software testing organizations, one of the things that you'll find is that they will admit to you that they hope to pick up 25% of the performance errors before you roll out. So that's a pretty significant number to me. Completely backs you up.
Yep. Okay. There's a good question here. What is the biggest difference between Kamanario and Nimble? Nimble is a great company. I guess you all heard it was also acquired by HP this week, but last week actually. But Kamanario has, it's an all-flash vendor, was always an all-flash vendor. Nimble started out, I think Jeff covered some of the, basic or fundamental functionality of having like a tiered architecture. So I won't go into all those details. I'm just going to say that, feel free to come online, kamanario.com, read our material. You'll see the main differences between how we compare to those hybrid models.
If I could say something about that, Shai. I'm not going to talk about Nimble direct because, honestly, I think congratulations to the guys at Nimble for, successfully being acquired. I hope that they all, got a good payday out of that. I genuinely do. But just from an architectural perspective, so Nimble is a system which is built on a active-passive architecture. It uses two controllers, and one is active, sending and receiving I/O requests. One is passive, And kind of the goal there is that if one fails, then you just switch over to the other one with, I would imagine, zero performance impact. Kaminario is a completely different kind of solution. The goal of Kaminario is to be independently scalable up and out. So scaling up means adding capacity, in database terms, adding more data. Scaling out means adding more performance. So, for example, adding more users to your database. And because of the ability that Kaminario has to do scale out, it means that all of our controllers are always active. So you can start with a pair of controllers for resilience. You can add another pair. You can go up to 4 pairs, 8 controllers, and every single controller will always be active. So you will get the full benefit of the performance of all the controllers. So it's a different architecture aimed to allow the ability to scale out performance.
Yep. Thanks, Chris. It's a good point. Another question from the audience, and might be the last one for today. Thoughts on RAID, right? Which RAID version or what RAID scheme would be recommended in an all-flash array deployment? And is this introducing unnecessary overhead in a flash all-flash array? So
can I take that one?
Yeah, definitely.
Can I just briefly? So Kaminario has its own RAID implementation. It's known as K-RAID. It's very, very clever, and it would take me far longer than we have left on this call to explain how it works, but we do have a white paper on it on the website. It's essentially a kind of, it's similar to RAID 6, and it has dual parity. But I think the question is, I get asked this a lot by database customers. So talking as an Oracle guy, right, Oracle, you typically use a volume manager called Oracle ASM, Oracle Automatic Storage Management. And in that, you choose a RAID level. And people often ask me, what RAID level should they choose at the database? And the answer is, you don't. You don't let the database do that, because everything on the all-flash array is resilient and redundant. So there's no need to ask Oracle to take care of RAID. You would use what's called external redundancy. Now, as we've established, I don't know much about SQL Server, but again, the concept is that you just allow the all-flash array to take care of that. You don't need to go through the very complicated process of thinking about, I'm going to have RAID 10 for my data files, I'm going to have RAID 1 for my redo logs, and RAID 5 for my archive logs, and all that kind of complication that you used to have with disk. It just goes with all-flash. You just have, a very simple layout of volumes, and everything's taken care of by the all-flash array.
Okay, cool. So I think we're just on top of the hour. I would like to thank Jeff and Chris for attending the webinar, and of course all the SpiceWorks community for joining us. If you have any questions, feel free to contact us at kaminario.com. And also you're going to have this webinar live in a short while.
Thank you very much.
Thank you all for your time today.
All right, fantastic presentation. Thank you so much to all of you. I do want to remind everyone that if you had to step out or miss any part of this presentation, you will be getting an email in just a couple of days with a link to view the webinar on demand. Also, if we were not able to get to your question live, somebody will be able to follow up with you. Want to say special thanks to all of our presenters today for taking time out of their day to present this great content. And special thanks to each and every one of you for tuning in today. We hope to see you back soon.